Today let me discuss the topic number base conversion. As the familiar number systems are decimal, binary, octal and hexadecimal number system. So if you wanted to convert from one number system into other number system, there is a possibility of, for each number system there is a possibility of 3 conversions are available. So total 12 types of conversions are there. So now today's session we will discuss about decimal to any number conversion. So decimal to octal or decimal to binary or decimal to hexadecimal number system. Now, so your numbers are mainly classified as a integer purely or a pure fractional part, or you also have your mixed number which contain both integer and fractional number. So we need to follow two separate procedures to convert your pure integer or a fractional number. So now let me first proceed with our integer conversion. So decimal integer is converted into binary. So here we need to proceed with the procedure of dividing your given number with a corresponding base. As the binary is having a base of 2, so divide your number with the base of 2. Take the reminders as your one bit of your equivalent binary or a coefficient, and then take the coefficient, again divide with the corresponding base of 2, and this process of successive division will be stopped where the coefficient becomes 0. Now, so I have taken an example with 13 is the decimal number. This I wanted to convert into equivalent binary. So now first I have taken the number and divided with the 2. So 2 6 are 12. So 13 minus 12, your remainder become 1. So that will be your least significant bit of your equivalent binary. And then the coefficient we have taken, and here we have divided with the 2. So 2 3s are 6, remainder is 0. So we consider that as a A1 as 0. Next, we have taken coefficient of 3 and divided with the 2. The coefficient become 1 and the remainder become 1. So as we have taken that as a A2 is equal to 1, and then so 1 divided by 2, 2 zeros. So 1 minus 0, 2 zeros is 0. So 1 minus 0 is, remainder is 1. So your coefficient becomes 0. So which indicates the conversion is completed. So now 13 to the base of 10 is equivalent to 1101. So writing all the reminders from bottom to top. So first remainder will occupy the least significant bit position. Last remainder will occupy the most significant bit position. So 1101 is your equivalent of your 13 in decimal. Next, to convert your fractional number of your decimal into binary, we need to follow a procedure of successive multiplication with corresponding base of 2. So multiplying your given number with a base of 2, you are obtaining a product where it contains both integer part and your fractional part. So take the integer part as your one bit of your equivalent binary fractional part conversion, and then proceed the multiplication till you get your fractional part is 0. So now we have taken an example 0.625 to the base of 10. So 0.625 into 2 is equal to, the product is 1.25. So the integer we are considered as a minus 1 is equal to 1. 0.25 is multiplied with a 2. So then we obtained a product of 0.5. So in this product 0.5, the integer part is 0. So we consider a minus 2 is equal to 0. Then the fractional part is 0.5. So here the fractional part is not at become 0. So we are continuing the process of multiplication with the base. So 0.5 we have taken and then we multiplied with the 2. So now we obtained a product of 1.0 where the fractional becomes 0. So this indicates your conversion of your fractional number is completed. Now writing all the integer parts from top to bottom, or your first integer number in a product will be the most significant bit, and the last integer number will be the least significant bit. So after your binary point, we are going to write it all the integer numbers as 101 to the base of 2. So 0.625 to the base of 10 is equal to 0.101 to the base of 2. For some examples, you may not get this fractional part. In order to obtain the accuracy, we can stop it after your 5 multiplications. So based on our precision, so how many multiplication they would prefer, that many after multiplications we can stop it, and we can write all the integers as its equivalent of your binary. Next, if they have given your mixed number, so which contain both integer part and fractional number, so those two separate procedure we are going to follow, and then we need to combine those results of integer conversion and your fractional conversion. Now 105 is my integer, so I have done with the successive division with the 2, and 0.15 is your fractional number, and hence we have just successively multiplied with the base of 2. So now when you are doing your successive division, 2 5s are 10, 2 2s are 4, which is remainder is 1. So next 2 2s are 4, and here 5 minus 4 is 1, so 12 will be there. 2 6 are 12, remainder is 0. So 2 13 26, remainder is become 0. 2 6 are 12, remainder is 13 minus 12 is 1. So 2 3s are 6, remainder becomes 0. 2 1s are 2, 3 minus 2, your remainder is 1. So 2 zeros 0, 1 minus 0 become 1 is the remainder. So the last remainder will be the most significant bit, and the first remainder will be the least significant bit. So writing here all the reminders from bottom to top, we would have your equivalent binary number of your given integer number 105, and 0.15 which is multiplied, which is a fractional number which is multiplied with the base of 2. The product contain, so 0.3, so your integer number is taken as your, this is considered as a first bit of your fractional part of your binary equivalent as a minus 1, and then 0.3 we were taking and multiplying with the 2, so we were obtaining a fractional of your 0. So this is considered as a minus 2, the second bit of your fractional number, and then so we are proceeding with the further multiplication since my fractional part is not become 0. So 0.6 is multiplied with the 2, 1.2, fractional is 1, and then 0.2 is multiplied with the 2, so 0.4. Next, here the fractional become 0.4, and then we are moving with the next multiplication with the 2. So your integer is here 0. So 0.4 we are taking for further multiplication. Then we obtain the product is 0.8. Here also the integer part is 0. And then 0.8 we are taking. So multiplied with the 2, 1.6. So now I stopped it here after 6 multiplication. So because you may not get this fraction is 0. So hence we stopped after your 6 multiplication and writing all the integers. So first a minus 1 will be the first bit of your fractional number, a minus 2 is your second bit, and writing all the integers from top to bottom. So we will get your equivalent, and we combine the result of your integer conversion as well as your fractional conversion, which gives you the equivalent of your mixed number decimal number 105.15 to the base of 10. Next, decimal number integer into octal. As octal base is 8, so your given decimal number is 175, so which is a purely integer. So we were dividing that 175 by 8, so with a coefficient of 21 and with a remainder of 7. So a naught is equal to 7, and then 21 we are taking, which is divided with the 8. So 8 2s are 16, 21 minus 16, we would obtain the remainder is 5. And now the coefficient is not 0. So 2 we are taking and 8 zeros 0. So 2 minus 0, your remainder becomes 0. So now your equivalent is 175 to the base of 10. It is equal to, so A2 occupies the most significant digit portion, A0 occupies the least significant digit portion. 257 to the base of 8 is your equivalent octal. So decimal fractional into octal conversion. Now we have taken a decimal fractional number 0.3125 to the base of 10. So since it is octal, so multiplied with your 8. So 0.3125 is multiplied with the 8. So the product will become 2.5. So now 2 is the integer. We consider that as a minus 1, the first digit of your octal number. Next fractional part is 0.5. So we have taken that and multiplied with the 8. So 4.0 is the product. Since we got the fractional is 0, so your conversion is stopped at here, and we were considered a minus 2 as a 4. So now 0.3125 to the base of 10 is equivalent to 0.24. So a minus 1 occupies the most significant digit and a minus 2 is the least significant, or writing your a top to bottom, your all the integer parts, a minus 1 and a minus 2. Next, in order to convert your hexadecimal in a decimal number into a hexadecimal number, so I've given an example of a mixed number which is having both the integer part and fractional part. So integer is successively divided with the corresponding base of 16. Fractional part is successively multiplied with the base of 16. So here upon successively dividing, so we have the coefficient, first coefficient is 162 and the remainder is 6. So here second, after the second division, so now 16 tens are 160. So 162 minus of 160, remainder become 2. So 16 zeros 0. So 10 minus 0 is 10. As 10 equivalent in your hexadecimal is designated with the alphabet letter A. So now writing all the remainders from bottom to top, which would give you the integer conversion of your given decimal number as A26 is your conversion of your 2598 into hexadecimal. Next 0.675 to the base of 10 is multiplied with the 16. So then we obtain 10.8 here, where 10 in hexa is designated with A and 0.8 is your fractional number. We were taking that for a further successive multiplication with the 16. Since we are not getting a fractional part 0, so if you are going on multiplying, you keep on getting here this repeated 12.8 only. So hence we are stopped here after your 4 multiplication, and we obtained all the integers from top to bottom. So first integer occupies the first digit of your fractional decimal conversion into hexadecimal as A, C, C to the base of 16, and we combine both the results of your integer conversion as well as the fractional conversion to obtain your actual equivalent of your given decimal number of mixed. So 2598.675 to the base of 10 is equal to 826.ACCC. So this is about today's session. In the next session, how to convert any number into a decimal. That topic we will discuss.